Hello, Assalamu alaikum, all viewers and dear students. Today we will start from first year books exercise 1.2, how to separate real and imaginary. Exercise 1.2, 1.2, question number 7, part 4. How to separate real and imaginary part. How to separate the real and imaginary parts. Two a minus bi whole power minus 2. Here exponent is minus 2. First of all, we use the exponent rule. We change into negative power into positive. So we use this exponent rule, x power minus m. So we can write x power 1 by x power m. So this is the one of the exponent rule. So the power is negative. So we change into positive. We divide by 1 this term. Similarly, we change this terms 1 divided by 2a minus bi whole square. Now we can write this term, we can also write 1 divided by 2a minus bi is a whole square. So 1 square is also 1. So now here in the denominator, the problem, iota gives the problem. So we will reduce this one. We are trying to finish this term. The complex number we change into another numbers. So this will be now consider multiply, we multiply, yeah, we divide or multiply and multiply by the conjugate of 2a minus bi conjugate is equal to 2a plus bi. So the sign is changed. If we take conjugate, so the sign is changed into positive. Now this term is reduced 1 divided by 2a minus bi, 2a plus bi, 2a plus bi. So we have already divide and also multiply. So the result is coming same. There will be no effect on the question. Now we multiply numerators to each other. 1 multiplied by 2a plus bi whole square we can write, and we can also use here the formula a minus b. This term consider to a and this will be considered b, a minus b, and here a is considered b, a plus b is equal to a square minus b square. Means that here a minus b into a plus b is equal to a square minus b square. We reduce this term into the form of this formula 2a whole square minus bi whole square, and taking the whole square is also here the whole square. Now expand these two terms, we get here 2a plus bi individually. We eliminate taking square on numerators and denominators. Here we get 4a square plus and b square iota square and whole square. Now expand this term by the formula a plus b whole square. We get a square plus b square plus 2ab divided by Here iota square is equal to minus 1, as we know that iota square is equal to minus 1. Here we substitute, and in place of iota square we put minus 1, or a square plus, sorry, minus we get here minus, sorry, here minus b square into minus 1 whole square. Now further simplify this terms. So 4a square plus b square iota square plus 2 multiplied by 4, 4ab iota, 4ab iota divided by 4a square plus minus into minus plus b square whole square. Now we are required to the question is that separate real and imaginary parts. Now we are trying to eliminate separate and real parts. Here in iota square, once again we put this result in the place of iota square minus 1, 4a square plus b square minus 1 plus 4abi divided by 4a square plus b square whole square. And here we get 4a square minus b square plus into minus minus b square plus 4abi divided by 4a square plus b square whole square. We are separate real and imaginary part. This is real and this is real. We can write together 4a square minus b square divided by 4a square plus b square whole square plus 4abi divided by 4a square plus b square is a whole square. So it means that this is the real part, and here 4ab is the imaginary part. According to the formula a plus b iota, this is the number of complex number. So it means that here real part is equal to 4a square minus b square and 4a square plus b square whole square. Imaginary part is equal to 4a square plus b square whole square. b plus 4 iota and 4 minus 3 iota whole power minus 2. Here the power is negative, so we will use against according to the exponent rule. We are changing this rules according. Here the rule is x power minus m 1 over x to power m, we change into positive. Similarly here we change into positive. 3 plus 4 iota divided by 4 minus 3 iota whole square. Now we write, it means that 3 plus 4 iota is square and denominator is also square. We separate to each other. 3 plus 4 iota whole square divided by 4 minus 3 iota whole square. Now we change this result to the numerator, so we can write 4 minus 3 iota whole square into 1 divided by 3 plus 4 iota whole square. Here is the double division. We change the denominator to the numerator, so this result we can put here a minus b whole square formula is used. A square plus b square minus 2ab divided by here a plus b whole square formula is used. A square plus b square plus 2a into b. So here we get 16 plus 9 iota square, and here we get minus 24 iota divided by 9 plus 4 plus 16 iota square plus 24 iota. Now here in the place of iota square, we put iota square is equal to -1. So 16 plus 9 into -1 minus 24 iota divided by 9 plus 16 into -1 plus 24 iota. Now here 16 plus into minus 9 minus 24 iota divided by 9 plus into minus 16 plus 24 iota. So this is the real part. Now we subtract this one, we get here 7 minus 24 iota, and 9 minus 16 we get -7 plus 24 iota. Now we are needed to, in the denominator term, complex number is coming. So we try to finish this term. Now what we will do, we divide and multiply by the conjugate of this one, -7 minus 24 iota, -7 minus 24 iota by the conjugate of the denominator term. Now we are multiplying denominator to each other. We get here 7 into -7 minus 24 iota minus 24 iota into 7 minus 7 minus 24 iota divided by, here in the denominator we can use a square minus 7 square minus 24 iota whole square. 7 we get minus 49. 7 multiplied by minus 148 iota. 7 multiplied by 4. 7 multiplied by 4, 28. 2 upskiri. 7 multiplied 14, 148. Similarly, we multiply minus into minus plus. We get 1 plus 148 iota, and here minus into minus plus 24 multiplied by 24, 576 iota square divided by, here 749 minus 24 squares, we can write 576 and iota square. In the place of iota square, we put -1. So look here, this will be cancelled. One is positive, one is negative. So minus 49 plus 576 minus 1, 49 minus 576 minus 1. So we get here minus 49 minus plus into minus minus 576 divided by 49 plus 576. If we add these two terms, we get here 15, 12, 6 minus and positive 625, both are cancelled. We get -1 and we change into the iota form, complex number we can write in this one. Now it means that if we compare with the formula a plus b iota, so the real part is a is equal to 1 -1. So this is the real part, and imaginary part b is equal to 0. So this will be imaginary part, which is the required result. So how we separate the real and imaginary part? So we can get the final result. A is equal to -1 is the real part and B is equal to imaginary. Number 8 is very important. So that Z plus Z conjugate is equal to 2 real of Z. We want to prove that Z plus Z conjugate is 2 real number of Z. So first of all, we taking left hand side. Suppose that, or we can say this, suppose that let Z is equal to A plus b iota. Now first of all we are needed that conjugate. We can write a plus b iota conjugate. So the sign is also changed, a minus b iota. Now we are taking left hand side. Left hand side is equal to z plus z conjugate. We replace the value of z, a plus b iota plus and a minus b iota. Look here, here is positive b iota and here is negative. We get here 2a. Now we are taking right hand side. Right hand side is equal to real part of z. Now look here z we know that a plus bi, and here real part of z is equal to a. Now it means that if we right hand side we multiply, in replace of real z we get a, so here is 2a. Now comparison of equation number first and second, comparing equation number 1 and 2, so we will get here left hand side is equal to right hand side. We can write left hand side is equal to right hand side. Both results are 2a. That means that here we can verify the both result 2 and 2 real part of z. Z bar is equal to minus z. If z is any pure imaginary number, pure imaginary number, then what is the result? We are want to show that z bar, z conjugate is minus, is equal to minus z. Now similarly, if z is any pure imaginary number, let's suppose that z is equal to a plus b iota is any complex number, then first we are needed taking left hand side z bar conjugate a plus b iota. So similarly we get here the sign is changed into the conjugate sign is changed. So this will be left hand side z bar, and right taking right hand side is equal to minus z minus a plus b iota. So here we get here minus a minus b iota. Then what we will do here, condition is if z is any pure imaginary number, it means that we put here the value of put a is equal to 0, because we are required z is any pure imaginary number. Then we put here z a is equal to 0. So the equation of left hand side becomes is equal to z bar is equal to, in replace of this one we will get here minus b iota. So minus b iota. Here b is pure imaginary number. Pure imaginary number. Similarly, if we put in the right hand side minus z we have already done, minus a minus b iota. If we put here 0 minus b iota, we get minus b iota. Minus b iota is also a pure imaginary number. So it means that left hand side is equal to right hand side. Left hand side is equal to right hand side. That will be equal to z bar is equal to minus z. Question number 9. F z is equal to minus 3 plus 2 iota. Verify that minus z absolute less than or equal to a real part of z less than or equal to z absolute. Now how we want to show that minus z absolute less than or equal to real part of z less than or equal to z absolute. Now first of all we find these three combinations. Let z is given that 3 plus 2 iota. So what we will do, first of all, we find z absolute according to the formula a square plus b square. Now here, if we compare, here is a plus bi, here a is equal to 3 and b is equal to 2. We put here 3 square plus 2 whole square root. So we will get here 9 plus 4 and we get here 13 under root. But in the question is asked from us minus z absolute, so result is minus 13 under root. Now a real part of z is equal to 3 plus 2 iota, that is compare with this form. Here it means that real part is 3 and imaginary part is 2. So we are required real part of z, real part of z. The real part of z we get here is a is equal to 3. A is real part. So here we are needed the third part z absolute according to the formula a square plus b square root. Here 3 square plus 2 square, we get here 9 plus 4, we get 13 under root. Now if we substitute the values in the above relation, look here minus z absolute less than or equal to real part of z less than or equal to z absolute. It means that we have already found, we get the answer minus 13 under root less than or equal to real part of z 3 less than or equal to 13 under root, which is the required result. It means that here minus 13 under root is less than from this result and 3 is less than from this result. So we can also verify the above. So this is called simultaneous linear equations. And how many methods we are used? So there are two methods are used and simultaneous linear equations. The first method is elimination method and the second is substitution method. And elimination method, first of all, we eliminate one of the variables and then put to the another variables. Or we can say that we are trying to finish one variable of the coefficient and the other variable to make like terms. So this will be equal and we put this result to another equation, we will get the another result. Similarly, in substitution method, we take supposition and we eliminate one variable to another variables, we put to the another equation. So we will get automatically another equation results. Now exercise 1.3. Question number first, solve the system of linear equation with complex coefficient z minus 4w Solve the system of linear equation with complex number. Look here. This is the simultaneous equation because there are two variables are used, z and w. We find the value of unknown variable z and w of the linear equation. Linear equation we have already discussed in the 9 and 10 class. Those type of equations which graphically if you draw it must be a straight line, but the variable exponent must be equal to 1. There are two properties in the linear equation we are using, but here we are using the system of linear equation with complex coefficient. It means that this is two or more equation are involved. So this is called simultaneous equation. Now we try to find z and w values. How we calculate? Now we are using elimination method or substitution method. We have already discussed. There are two methods we are using. Now in elimination method, we try to compare the coefficient of one variable and make them like similar, then subtract to each other. Now look here, if we check here the coefficient of z1 is z is 1 and z is also, the second equation is z is also 1, so both are same. It means that if you directly subtract this equation number first and second, then we will get the value of w. Now we subtracting equation 1 and equation 2, we get z minus 4w 3 iota z plus 3w is equal to 11 minus 5 iota. Here is positive and subtraction we change the sign, so this sign is finished, and here is positive, this will be negative, here is negative, so it will be positive. It means that the sign is changed. So and subtraction, so the sign is also changed. Z minus z, this will be cancelled, minus 4 minus 3w, so we will get minus 7. Here is minus 11 and plus 3 plus 8 iota. It means that here requires w values, so dividing both sides by minus 7. Both are cancelled. W is equal to minus 11 plus 8 iota divided by minus 7. We put, we give here third equation. We put third equation. In any equation we will get z values. Look here, if we put here in the first equation, put equation number third and first, so we will get here z minus 4 into minus 11 plus 8 iota divided by minus 7 is equal to 3 iota. Now we change this term, look here. So z minus multiplied by this term, we can write minus into minus plus 4 into minus 11 plus 8 iota divided by 7 is equal to 3 iota. If we change this term directly here, so z is equal to 3 iota plus change into minus 4 into minus 11 plus 8 iota divided by 7. So here LCM is 7. 7 multiplied by 3 we get 21 minus 4 into minus 11 plus 8 iota. Now we open this term. Z is equal to 21 iota minus into minus plus 44 minus 32 iota divided by 7. So Z is equal to 44 is constant, so imaginary part 21 and minus 32, we will get here minus 9 iota. minus 9. Yes, minus 9 if we add 1, no sorry, 1 and 1, minus 11 divided by 7. So this is the value of z and w unknown variable we will get here. Z is equal to 44 minus 11i. So the solution of linear system of inequation have there are two variables, we get two results. W is equal to minus 11 divided by 8 iota minus 7 and Z is equal to 44 minus 11 iota divided by 7. Third part 3Z plus 2 plus iota W is equal to 11 minus iota. 2 minus iota Z minus 1 plus iota. Now here look here, we give two equations. Here are two unknown variables z and w are used, and there are two equations and two variables are used. So this is called system of linear equation. We try to solve the solution of z and w will use. How we will get? If we use elimination method, it means that here we multiply 2 minus iota term multiply by the first equation and 3 multiply by the second equation. Now we can write we multiply equation number first by 2 minus iota and equation number second by 3 and subtracting to each other and subtracting to each others, then we will get one of the term is z will be 0. Now according to the condition, equation number first we multiply by 2 minus iota, equation number first we multiply by this term 2 minus iota into 3z plus 2 minus iota 2 plus iota w 2 minus iota 11 minus iota. Now first of all we simplify this term, then we multiply by second equation 2 by 3. Now if we write here, look here, we can write 6 minus 3 iota into z plus here we use formula a square minus iota square into w. Here we multiply 2 into 11 minus iota 11 minus iota. We multiply by this term and secondly multiply by minus iota. Now 6 minus 3 iota into z. Here we get 4 and replace of iota square we put minus 1 and multiply 22 minus 2 iota minus 11 iota plus iota square. Now further simplification, 6 minus 3 iota into z plus minus minus plus 1 plus 5 w, and here we will get iota square minus 1 22. Here is minus 2 iota minus 13 iota and minus 1. We can simplify this one, 21 minus 22 minus minus 1, we get 21 minus 13 iota. So we give the equation number third. Now we are coming back equation number 2 by multiply by 3. So here we multiply by equation number second becomes 3 into 2 minus iota into z minus 3w is equal to 3 into minus 1 plus iota. First we simplify this one, we will get here 6 minus 3 iota into z minus 3 w is equal to minus 3 plus 3 iota. Give equation number 4. And already we have subtracting to each others. Now we subtract these two, third and fourth equation. So here is third is 6 minus 3 iota into z plus 5 w is equal to 21 minus 3 iota, and 6 minus 3 iota into z plus minus 3 w is equal to minus 3 plus 3 iota. Subtracting, so sign is changed. Here is plus negative, so both are cancelled. Here is plus 8 w and here both are minus 24 minus, we get here minus 6 iota. If we dividing both sides by 8, 24 minus 6 iota divided by 8, so both are cancelled. W is equal to, here we can also common 6 if we common, so 2 is common, yep, 2 is common, 12 minus 3 iota divided by 8, 2 1 2 4, so we will get here 12 minus 3 iota divided by 4. One of the result we get W is equal to 12 minus 3 iota divided by 4. Now we put this result in equation number first, plus 2 plus iota W iota 11 minus iota. We put in replace of W, we put this result, then we will get simplified 3z plus 2 plus iota into 12 minus 3 iota divided by 4 is equal to 11 minus iota. Now we taking LCM of this one, 4 we can write 12z plus 2 plus iota into 12 minus 3 iota is equal to 11 minus iota divided by 4. 12z plus, we can open this one, 24, 2 and 2, 12 minus 3 iota plus iota 12 minus 3 iota into 11 minus iota into 4, means that we multiply here 4 and here both are cancelled and here we multiply by 4. Now expand this terms, 12z plus 24 minus 6 iota plus 12 iota minus 3 iota square is equal to 44 minus 4 iota. So we compare the like terms, iota, this will be iota plus 24 plus 6 iota minus 3 into minus 1, in the place of iota square we put minus 1, and here 44 minus 4 iota. If we 12z plus, here is 24 minus minus plus 4 plus 6 iota plus 4, sorry, plus 3 is equal to 44 minus 4 iota. Now 3 and we get right, 12z plus 27 plus 6 iota is equal to 44 minus 4 iota. Now we change this value to the right side. So the sign is also changed. 44 minus 4 iota. Complete this term minus 27 minus 6 iota. So further simplification, and here we get 7 and 1. 44 minus 27 is 17, and minus 4 and minus 6 iota, we will get here minus 10 iota, and here dividing both sides by 12. 12 is equal to minus 17 minus 10 iota divided by 12. So both are cancelled. So we will get here z is equal to 17 minus 10 iota divided by 12, which is the required unknown variable value of z and w. Thank you very much for watching, and once again thanks to give the time for watching.